Hey guys, today we're going to be looking at some other kinematics equations. Now, kinematics equations relate velocity, acceleration, displacement, and time. So our acceleration question we looked at yesterday didn't use displacement in it. So you could see how much an object's speed or velocity changed over time, but you couldn't actually see how far it went during that process. Today we're going to be using 4 equations. 3 of them are new. This first one we learned yesterday, but the other 3 are new, and they relate delta x, which is change in position, with a bunch of the other variables. So you're going to see the VFs, VIs for velocity final and velocity initial, as well as acceleration, and we're just going to start using t as delta t. So really what we're going to do is some example questions. And when you read each example question, you're going to have some given information. You're going to need to take that given information and match it with an equation. And we're going to do this by reading example problem 1. It says, how far does a car travel if it goes from rest to 27 meters per second in 2.8 seconds? And we're going to use the I guess method just as always. However, for this, for today only, for just the acceleration notes 2 and the acceleration practice for today, we're going to ignore the graph. We're going to be looking at graphing much more in depth tomorrow. On Friday, we're going to talk about translating graphs a lot and do some practice there. So we're not going to actually look at the graphs today. You can skip that part, and that's the I. You can skip the I. But we're going to work with the G and the U to start with, the givens and the unknowns. In this question, you've got a given where it says it goes from rest. If it goes from rest, that means your velocity initial is 0 meters per second. And then it ends up at 27 meters per second. So that's the velocity final. Velocity initial and velocity final. And then it gives us a time, 2.8 seconds. So delta t equals 2.8 seconds. Now, yesterday we had this exact same problem, except it asked for acceleration instead of how far. The question, how far, is talking about delta x. So what we're going to look for is an equation that has VI, VF, delta t, and delta x in it. We're going to go through the different equations. This first equation, this one, has VF, which we have, VI, which we have, but it also has A. A doesn't show up anywhere in our problem, so it can't be that equation. Let's try the next one down, this one. It's got VF, we have VF. It's got VI, we have VI. It's got a 2, which is just a number, A, which we don't have, that doesn't appear anywhere in our thing, and delta x. So it can't be this one. Now up here we've got delta x. Delta x is what we're looking for. Perfect. VF and VI, we have both of those, and delta t, which we have. So this equation seems to work perfectly. And we can eliminate the bottom one because it's got an A in it, which we don't have and we're not looking for. So we're going to use this top right equation. I'm going to put delta x equals VF plus VI over 2 times delta t. And that is conveniently already solved for our unknown, which is delta x. So we don't have to do any algebra this time. Lucky us. Now we get to substitute delta x equals VF plus VI, which is 27 plus 0 divided by 2 times delta t, which is 2.8. So we're going to do 27 divided by 2 times 2.8. Let me get my calculator out really quickly. And that's going to be 27 divided by 2 times 2.8 equals 37.8. And that's 37.8 meters, because it is a delta x. So all we had to do was read the question for the givens and the unknown, match those to an equation, and then write down the equation, substitute in, find a solution. Easy peasy. Now let's go look at a couple more examples just so you know what you're doing. All right, I'm going to write down the equations over here on the side because we need them still. Give me a second to do that. All right, there's all 4 of our equations. Let's read example number 2. It says, what is the acceleration of a cheetah that starts at rest and travels 40 meters in 13.5 seconds? We're going to ignore the graphs for today. Look at just the givens and the unknowns. So the given here is, or one of the givens is that it starts at rest. So that's, once again, a VI equal to 0 meters per second. Our next given is that it travels 40 meters. If it travels 40 meters, that's a delta X equals 40. And then it goes for 13.5 seconds, that's a delta T. Those are all the givens. The unknown is the acceleration. Acceleration equals question mark. So we need to find an equation that has VI, delta X, delta T, and A. And that equation is going to be, if you look through all of them, go ahead and look through all of them, try to figure it out. The one that has all of those things and nothing extra is this bottom one. Delta X equals VI delta T plus 1/2 A delta T squared. Just write that down on the equations. Delta X equals VI delta T plus 1/2 A delta T squared. And then you have to solve that for A, because we're looking for A. In order to solve that for A, I'm going to zoom in a little bit here. So I've got a little bit more space to work with. Solving that for A. To solve this for A, you first have to get rid of the VI times delta T on both sides. And you get delta X minus VI delta T equals 1/2 A delta T squared. Great. Now we have to get rid of the 1/2. In order to get rid of the 1/2, you have to multiply both sides by 2. So you get 2 times delta X minus 2 times VI delta T equals A delta T squared. And lastly, to solve for A, you have to divide by delta T squared on both sides. Then you get to substitute. You've got 2 times delta X is 2 times 40. Delta X was 40. Minus 2 times VI. VI is 0 times delta T, which was 13.5. And then divide all that by delta T squared, or 13.5 squared. Now 2 times 0 times 13.5 is just 0, so that term conveniently goes away because it's just 0. You get 2 times 40 divided by 13.5 squared is, gotta whip out the calculator, 2 times 40 divided by 13.5 squared is 0.439 meters per second squared. Now, you can, if you would like, instead of solving the algebra beforehand, you can just plug in numbers and solve after that. It is actually a fair amount easier if you don't like algebra. So, if you don't like the algebra, totally fine to plug in numbers before you solve the equation. All right, let's look at our last example. Our last example asks, what is the final speed of an object if it starts at 2 meters per second and accelerates at 3 meters per second squared over a displacement of 10 meters? So we're going to write down all the givens, figure out what we're looking for, pick an equation, substitute, and solve, just like last time, ignoring the graphs. Our first given is that it starts at 2 meters per second. The starting velocity is VI, and it's 2 meters per second. Then it says it accelerates at 3 meters per second squared. So we've got acceleration equals 3 meters per second squared. And the displacement or change in position is 10. So that's delta x equals 10. And the question asks, what is the final speed? So VF is our question mark. Next up, we have to choose an equation that has all of those things in it. Looking back, oh, I have lost my equations. Well, if you go look at them on the other page on your notes, you'll see that the correct equation that has all of these things in it is VF squared equals VI squared plus 2A delta X. It's got VF and VI, and it's got acceleration and displacement. So this time, instead of doing the algebra first, I'm going to plug in numbers first and then solve. You can do it whichever way you prefer. But I'm going to go ahead and directly substitute. We don't have a number for VF because it's what we're looking for, so we leave it alone. So that equals VI squared. VI is 2. I'm going to square 2 plus 2 times acceleration, which is 3, times delta x, which is 10. So this all turns out to be a pretty nice number. 2 squared is 4, plus 2 times 3 is 6, times 10 is 60. So you get VF squared equals 64. Then you have to square root 64 because you're looking at VF squared and you need VF. So in order to go backwards, to do the inverse of that, you have to take the square root. You get VF equals 8 meters per second. All right, and that should do it. All you got to do for each of these questions is write down your givens, figure out what your unknown is, choose an equation, substitute, and solve. Please let me know if you have any questions. Just complete this practice today, and tomorrow we're going to look more at graphing.